All right, let's talk about something that's becoming absolutely critical for anyone building with AI. We're going to explore why the AI applications of tomorrow, the really smart ones, need way more than just a simple, straight line of thought. It's time to go beyond those basic chains.
So let's just dive right in, because I think this question hits home for a lot of us. You know that feeling, right? You've built an AI workflow using a simple chain, it follows steps A, then B, then C, and it works. Kinda. But the second a real-world problem shows up, something that needs it to maybe rethink step B or remember what it learned in step A, the whole thing just breaks. It's a checklist follower, not a problem solver.
So, before we get to the solution, let's really unpack the problem. Why do these basic, sequential AI workflows, these chains, fall short so often when the training wheels come off? I mean, this slide just lays it out perfectly. Look at the contrast here. On the left, you've got linear chains. They're rigid, they're sequential, and most importantly, they're forgetful. They're what we call stateless. They have no memory of what came before. It's a one-way street with no U-turns. But real life, real tasks, they're the complete opposite. They're dynamic, they require memory or state, and you absolutely have to be able to reevaluate and try again. It's really the difference between a simple assembly line and a bustling workshop full of experts who can collaborate and adapt.
And that's the bottom line, isn't it? Simple chains have been amazing for getting us started. They're fantastic for prototypes, for basic chatbots, for proving an idea can work. But they hit a hard ceiling, a wall, the moment you throw any real complexity at them. They just weren't built for tasks that need memory, iteration, or sophisticated decision-making.
Okay, so that brings us to a really powerful shift in how we think about building AI agents. This is where we move past the limitations of a straight line. Let's see how we can build something much more powerful by thinking not in lines, but in webs, in cycles, in graphs.
And here it is, LangGraph. Now this isn't just a small update to the old way of doing things. It's a totally different approach. It replaces the idea of a linear chain with a graph. And the two most important words on this slide are stateful and cycles. Stateful means it has a memory. It knows what's happened. And cycles, that's the game changer. The ability to create loops is what unlocks real agent-like behavior. It lets an agent try something, look at the result, and say, huh, that didn't work, let me try something else. You know, just like a person would.
And this image is a perfect illustration of the kind of thing we're talking about. A user asks a question, and the agent has to do a bunch of things. It might need to call one tool to find a project ID, then use that ID to call another tool to get a list of people on the project. But what if a name is missing? A simple chain would just fail. A LangGraph agent can actually decide to loop back, to try searching a different database, to keep working the problem. It's an iterative process, and that's exactly where a graph structure shines.
So, how do we actually build this AI brain? It sounds complicated, but it really boils down to three core concepts. This is how we architect that adaptive state and logic.
This right here is the blueprint. It's how you build your agent's brain, and it's simpler than you might think. First, you define its memory, the state. This is basically just a shared notebook that every part of the system can read from and write to. It's the agent's evolving understanding of the world. Second, you create nodes. Think of these as your specialized workers. Each one is a function that does one specific job. And third, and this is the really cool part, you wire edges to connect them. These are the pathways in the brain. And by using conditional edges, you create decision points. You give the agent the power to choose its own path to create those self-correcting loops. That's where the magic really happens.
And you should know, this whole idea isn't just some clever programming trick. It's grounded in some of the most important AI research out there, like the React paper. The core idea is that an agent should operate in a continuous loop. It reasons about what to do, it acts, and then it observes the result. LangGraph gives us the perfect framework to build these powerful reason-act cycles. It lets our agents truly think, act, and then learn from what happened to decide what to do next.
Okay, so we've got the architecture down. We know how to build the brain. But an AI brain locked in a box isn't very useful, right? So let's see how this power actually translates into real-world applications that can connect to the outside world.
And this is absolutely crucial. LangGraph was built from the ground up to be part of a bigger ecosystem. Your agent's actions, those nodes we talked about, aren't just thinking, they're doing. They're making calls to things like web frameworks, cloud services on AWS or Google Cloud, hitting any external API you can dream of, weather, financial data, you name it, and querying databases. This is how your agent actually gets things done in the real world.
And this image really captures that enterprise blueprint we're talking about. We're not just writing little scripts anymore. We're architecting professional, production-ready AI systems that can reliably interact with a complex digital ecosystem. We're building agents that can execute real tasks in a way that's robust, monitorable, and ready for prime time.
So why is this such a big deal right now? As we're barreling towards 2025, why is this shift from simple chains to complex graphs something every developer needs to have on their radar today?
Here it is. This is the key takeaway for all of this. The entire industry is shifting. We're moving away from AIs that just answer questions to AIs that can complete complex, multi-step jobs all by themselves. For any serious autonomous workflow, this kind of agentic, graph-based AI isn't a nice-to-have anymore. It's becoming a non-negotiable, critical skill for building the next generation of AI solutions. And really, that's the future we're building right now. It's the difference between an AI that can follow instructions and an AI that can reason, adapt, and pursue a goal on its own terms. So the question we all need to start asking isn't just, what can my AI answer? It's, what can my AI achieve?